Hello, my name is Antero Olila. This is climate lesson number 2, greenhouse effect. This is the energy balance of the Earth, including the greenhouse effect. Here I have the surface of the Earth, the atmosphere, and the space. The incoming solar radiation is 342 watts per square meter. All the fluxes in these presentations are in watts per square meter, so I may leave them out in some places. Part of the incoming radiation is reflected from the clouds and from the atmosphere. Part is reflected from the surface, and totally the amount is 31% from the incoming radiation, which is reflected back into space. It's called albedo, and it has no warming effect on the Earth. The warming effect originates from two fluxes. Clouds and atmosphere absorbs 71, and the surface absorbs 166. Totally, it makes 237 watts per square meter absorbed, and this is the amount keeping the life going on the Earth. And according to the energy conservation law, what comes in must go out. Therefore, the outgoing long-wave radiation must be exactly the same, 237 watts per square meter. In order to illustrate this amount, I have here 1 square meter, and I have 4 bulbs having a power 60 watts each, and totally they make 240 watts per square meter. You may think that that's not too much, but we should remember we receive it all the time on each square meter on the Earth. How is this outgoing long-wave radiation formed up? We can start from the emitted radiation flux from the Earth's surface. It's 396. According to the law of Planck, it corresponds to the surface temperature of 15.9 Celsius degrees. As we know, the surface temperature in average is about 15 degrees. So there is a small difference, but that's not too much. So it's very nice to have a good theory which explains why we have this much emitted transmission from the surface. Then part of this, and major part, is absorbed by the greenhouse gases in the atmosphere, 312. And part of the radiation tries to escape into space, but the clouds absorb about 67% of this radiation, because the average cloudiness of the Earth is 67%, and only 29 watts per square meter is transmitted directly into space. The greenhouse gases atmosphere emits upwards 168 watts, and the clouds emits upwards about 40 watts per square meter. And then we have downward emitted flux from the atmosphere or from the greenhouse gases. And as we can see, This value 345 is bigger than observed from upward going energy flux. According to the Kirchhoff's law, the energy absorbed and emitted by a medium, in this case greenhouse gases, must be equal in equilibrium. So, according to this theory, downward should be equal to the upward radiation flux. But we should not forget this flux, 71, which is also absorbed by the atmosphere and clouds. So totally everything is in line with theory. Somebody might ask, are these fluxes just theoretical calculations, or can we measure those fluxes? The answer is yes, we can measure, and a major part of these fluxes have been measured and can be measured. Incoming, outgoing energy flux, reflected by the surface, and absorbed by the surface. So these two fluxes, reflected by the clouds and absorbed by the atmosphere and clouds, must be calculated. Outgoing long-wave radiation can be measured as well, emitted and absorbed radiation fluxes. These four fluxes must be calculated, and therefore in different presentations you can find different values. To make the energy balance complete, we need the values of two energy fluxes, and they are thermals and latent heat flux. Somebody might also wonder how it is possible that the primary energy, 237 watts, it's much smaller than the secondary energy fluxes, which is coming down from the greenhouse gases. But this is exactly the greenhouse gas effect. It's not, there is nothing wrong with the theory. It really works like this. There is not energy created from nothing. It's not the perpetual motion machine, but it really works like this. This phenomenon can be found also in some other places. So this is not exceptional. One thing more, how we calculate the magnitude of the greenhouse gases. The most usual way is to start from the outgoing energy flux, which is 237 watts per square meter, and it corresponds the surface temperature of 18 degrees according to the Planck's equation. But we know that the actual surface temperature is 15 degrees thanks to the greenhouse effect. And this difference between these two temperatures is 33 degrees. And that's the most common and the simplest way to calculate the magnitude of the greenhouse effect.